Imagine for a moment the most extreme destination in the entire universe. A place where gravity is so intense that nothing, not even light itself, can escape its grasp. A point of no return. We're talking, of course, about a black hole. For centuries, these cosmic behemoths have existed only in the realm of theory and distant observation. They are the monsters lurking in the dark corners of the cosmos, the ultimate manifestation of gravity's power. But now, a bold new proposal is on the table, one that could transform our understanding of everything. A team of visionary astrophysicists is seriously planning to do what was once considered pure science fiction: send a robotic emissary, a spacecraft, on a one-way trip to visit a black hole. This isn't just a flight of fancy. This is a meticulously planned concept, born from decades of scientific progress. Before we dive into the mission itself, let's get a handle on what we're dealing with. So, what is a black hole? In the simplest terms, a black hole is a place where an immense amount of matter has been squeezed into an incredibly tiny space. Think of a star many times more massive than our own sun, compressed down to the size of a city. The result is a gravitational field so powerful that it creates a cosmic trapdoor. Once you cross a certain boundary, known as the event horizon, there's no turning back. The reason they are called black is because their gravity is so strong that even light, the fastest thing in the universe, cannot escape. This means we can't see them directly with telescopes in the traditional sense. It's like trying to spot a black cat in a coal cellar at midnight. Instead, we detect their presence indirectly, by observing their effects on the stars and gas around them. We see gas being pulled in, heated to millions of degrees and glowing brightly in X-rays just before it vanishes forever across the event horizon. So, how would we actually do this? The proposal, spearheaded by a team of leading astrophysicists, is as elegant as it is ambitious. The plan doesn't involve sending humans, the dangers are far too great. Instead, we would send a highly sophisticated, durable robotic probe. The target wouldn't be just any black hole, but likely a quieter one, perhaps a solitary stellar mass black hole not actively feeding on a companion star. The primary goal is to get the probe as close as possible to the event horizon, the point of no return, and have it transmit data for as long as it can. The probe would be equipped with a suite of instruments designed to measure the extreme environment around the black hole. It would map the gravitational field with unprecedented precision, testing Einstein's theory of general relativity in ways we never could from Earth. It would also search for something called Hawking radiation, a theoretical type of radiation that Stephen Hawking predicted should be emitted by black holes. One of the most mind-bending aspects would be to observe the effects of time dilation up close. As our probe neared the event horizon, its onboard clock would tick slower and slower. From our perspective, the probe would seem to freeze in time at the edge of the black hole, its signals becoming ever more stretched out until they fade into nothing. Embarking on such a mission is, without question, the most challenging feat of space exploration ever conceived. First, there's the sheer distance. We would need a revolution in propulsion systems, perhaps something like nuclear fusion rockets or laser-pushed light sails to make the trip within a reasonable time frame. Then there are the dangers of the destination itself. A black hole's neighborhood is not a friendly place. As the probe gets closer, the gravitational pull on the front would be significantly stronger than on the back, stretching it apart in a process colorfully known as spaghettification. Communication presents another massive challenge. We would need extremely sensitive receivers on Earth, perhaps a global network of radio telescopes. And finally, there's the fact that this is a one-way trip. There is no coming back. It's an all-or-nothing gamble. So, with all these risks and challenges, why do it? Because the potential payoff is nothing short of revolutionary. A successful mission to a black hole would fundamentally change our understanding of the universe, potentially rewriting textbooks and reshaping our view of reality itself. The technological impact would be immense as well. These innovations would ripple throughout our society, leading to advancements in energy, computing, materials science, and robotics. Ultimately, this is about more than just science and technology. For all of human history, we have looked up at the night sky and wondered. It would capture the imagination of the entire world, inspiring a new generation of scientists, engineers, and dreamers. It would be a testament to the human spirit's desire to explore, to understand, and to reach for the stars, and even for the shadows between them. What do you think? Is this audacious plan a brilliant next step for humanity or a cosmic folly? Is the knowledge worth the incredible cost and risk? Let me know your thoughts in the comments below. Let's keep this conversation going. And as always, keep looking up. Thank you for your time. Don't forget to like, comment, and subscribe for more deep dives into the cosmos.